Hello students, today we will see lecture 6 on rectifiers and I am Shayandev Ghosh. In the previous lecture we have learned about the uncontrolled rectifiers, controlled rectifiers, and in this lecture we will learn about the semi-controlled rectifiers, also known as the semiconverters. We have seen that in uncontrolled rectifiers we used elements like diodes, whereas in control rectifiers we use thyristors. In semi-controlled rectifiers, both the controlled elements and uncontrolled components are present. As you can see over here in this diagram, there are two thyristors T1, T3, and the downward two thyristors are replaced by diodes D2 and D4. So, how this circuit operates? Here RLE load is connected. So now let us focus on its performance and the waveforms. So initially, suppose we have in this positive half cycle, at this point alpha, triggering of T1 is done. So T1 is triggered at alpha. When T1 is triggered at alpha, T1 starts to conduct, and in diode 2 it is already forward biased, no external triggering is required. Hence current flows from the source through T1 to the load and then through D2 to the source. In this way it conducts till pi. Now what happens after pi? After pi the polarity changes. So there is a change in the polarity of the input voltage. Now due to the presence of this inductor, we have already seen that the thyristor will be still in the conduction mode. So the thyristor is conducting, diode is conducting. Now when the input voltage crosses pi, the polarity reverses, and at that moment what we can see, that this positive potential is applied to the anode of diode D4 and the negative potential is applied to the cathode of diode D4. So there we can see that just after that pi, D4 becomes forward biased, and when D4 becomes forward biased, what happens? The positive polarity is applied across the cathode of D2, negative polarity is applied across the anode of D2. As you can see, since this one is turned on, mind it, this one becomes turned on, so this one is short circuit. So the negative potential is applied to the cathode of diode D2, and hence D2 becomes reverse biased. So D2 becomes reverse biased. In this moment what we can see, that only T1 and T2 and D4 conducts. When T1 and D4 conducts, it means that the entire current through the load will flow through D4, T1 like this. So the energy stored in the inductor will be dissipated through this D3, D4, T1, RL in this circuit, in this closed circuit. So here we can see that during this moment after pi, a freewheeling action is occurring. So when the freewheeling action is occurring, it means that the load is entirely shorted. That means we get zero output voltage. So as you can see over here, we get 0 output voltage. When at pi plus alpha T3 is triggered, when at pi plus T3 is triggered, T3 starts to conduct, and when T3 starts to conduct, we can say that T1 becomes reverse biased. So when T1 becomes reverse biased, T3 and D4 conducts. So again we can see that there is an increase in the output voltage, and like this way we can see the output voltage. And here also just locate, as we have told earlier, that at this pi minus theta, when the input voltage magnitude of the input voltage becomes less than the back EMF E, current starts to reduce. And again when we turn on this thyristor T3, again the forward current starts to increase. So again the load current starts to increase. This is as similar as we have seen in the single phase full wave rectifier with RLE load. But here the only difference of operation between the single phase full wave rectifier with RLE load and the semi-converter operation is that during the fully controlled, the current was the voltage waveform was something like this, but during this semiconductor, during this region during pi to pi plus alpha, this region the output voltage becomes 0 due to this freewheeling action of the combination of thyristors and diode. Here is another configuration of semiconverters where two thyristors are connected in the same leg and two diodes are connected in the same leg. So now I will just request my students to just put an effort and just find out the input and the output voltage. This one will be this is the output. So draw the input and the output voltage and current waveform for this circuit and find out the average and RMS values. Okay, this will be very interesting if you just try to do this. So with this I end this lecture. Thank you.